Now we'll look at how to solve quadratic equations. We'll have three different ways of solving quadratic equations, and the first is by factoring. So again, this should be something that you've done previously, but if you're having trouble remembering, there are videos in the optional prerequisite material videos section near the bottom about factoring. There's also some on my YouTube channel under, again, searching my name, and then they're found in Foundations of Algebra playlist, so you could look there as well. So the idea behind factoring when we're solving equations is that we need to move everything to one side first so that it equals 0, and then we factor, and then we set each of the factors, each of the pieces equal to 0 to solve the smaller equations. So let's look at a couple examples here. In example 1a, there are two terms and they have some things in common. They both have a 3 that can go into them and an x that can go into them. So we'll pull out the 3 and the x, and we'll write our parentheses and keep the minus sign. So we ask ourselves, 3x times what gives us this 3x squared? And the answer would be x. And then 3x times what gives us 9x? And the answer would be 3. So this is factored now. Still equals 0. So here's one factor, 3x, and here's another factor, x minus 3. So we take the two factors and set them each equal to 0, and then we can solve them. So here we just divide both sides by 3 and we get x equals 0. And here we would add 3 to both sides, and we would get x equals 3. So there's two answers here. You could write them as a solution set, 0, 3, or just x equals 0, x equals 3. Or sometimes we would write x equals 0, comma, 3. That just means, again, that x can be 0 or x can be 3. If you replace x with 0 in the original problem, you'll find that it works. And if you replace x with 3 in the original problem, you'll find that it works. Quadratic equations are equations that have an x squared in the problem, and that exponent of 2 tells you that there are two answers. So there's our two answers, x equals 0, x equals 3. In part B, we need two numbers, because there's three terms, we need two numbers that multiply together to get 10 and add together to get -7. So if we think about the 10, we have 1 and 10 or 2 and 5. 2 and 5 work almost, but if we use 2 and 5, we get a +7 instead of a -7. So we need a -2 and a -5. And again, a -2 and a -5 give us a +10. So we can factor that. X minus 2, x minus 5 equals 0. Again, this gives us two factors. The x minus 2 we equal to 0 for one factor, and x minus 5 equal to 0 for the other piece. And we'll solve each of those. So here we'll add 2 to both sides, and we get x equals 2. So there's one answer. Here we'll add 5 to both sides. So that gives us x equals 5 for our other answer. Method 2 is to use the square root property. So the idea here is that we get the thing that's being squared by itself on one side of the equal sign. We take the positive and the negative square root of both sides, and then we solve for x. Again, because it's a quadratic equation, there should always be two answers. So that's why we have to do a positive and a negative square root. So let's look at example A. In example A, the x squared is the thing that's being squared. So we have to get it by itself first. So we'll add 21 to both sides. So we get 3x squared equals 21. And then we'll divide both sides by 3. So we get x squared equals 7. And then we'll take the square root. But when we take the square root, we have to take the positive and the negative square root. So we get x equals the positive square root of 7 and x equals the negative square root of 7. In example B, we have to do the same sort of thing. The item that's being squared is x squared. So we would subtract 45 from both sides. So we get 5x squared equals negative 45. And then we divide both sides by 5. And we get x squared is equal to negative 9. Then we take the square root, positive and negative. And so we get x equals positive, and we talked about this in 1.4, but the square root of negative 9 would be 3i. So we'd have a positive 3i, and x equals a negative 3i. Now in part C, it's a little bit different because the thing that's being squared in C is the part that's in parentheses. So it's already by itself on one side. So we start by taking the square root and then the positive and negative square root. So we're left with x plus 5 equals the square root of 11. Or the other equation would be x plus 5 equals the negative square root of 11. So in both cases we'd subtract 5 from both sides, but because this 11 is inside a square root and this 5 is not, we can't put them together. So we'd have negative 5 plus the square root of 11, and we would just leave it like that. Up here, when we subtract 5, again, the 5 is not inside the square root, but the 11 is, so we would just have x equals negative 5 minus the square root of 11. And then our final answer works for every quadratic equation. We'll talk about in a second how to tell which method to use for which problems. But you still have to have it equal to 0 first, and then you use the formula. And the formula says that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Anytime we're sticking in a number in place of that a, b, or c, we want it to be in parentheses. That's why I put each letter in parentheses. So in this problem, we're going to use the quadratic formula again. It's already in the right format. We have the x squared first, and then the x, and then the number, and then 0. So it tells us that a is 2, b is 2, and c is negative 1. So we'll write down the formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then I'll replace those letters with the numbers. So the opposite of 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 1 all over 2 times 2. And I always do this simplifying sort of in 3 pieces. So I would do this part first. X equals. Opposite of 2 is negative 2. Plus or minus. I'm going to leave that square root for a second. I would type this into my calculator just exactly like you see it. Parenthesis 2, parenthesis squared, minus 4, parenthesis 2, parenthesis, parenthesis 1, parenthesis. And if you do that, you get negative 4. So I replace that underneath that square root all over. And then I do this part, 2 times 2, which is 4. So it already looks a lot simpler. Then we need to deal with the square root part. And that we've talked about in the last section. So we would have negative 2 plus or minus. And the square root of 4 is 2, with a negative means 2i. And then because this has got an I in it, we want to write it in the right format. The right format would be that we take each one of these numbers and we divide by 4 So we have 2 over 4, negative 2 over 4 plus or minus 2 over 4i. We'd want to reduce that. 2 over 4 is the same as 1 over 2, so we'd have x equals negative 1 over 2 plus or minus 1 over 2i. And that's really two answers. Sometimes your homework wants you to write them out separately, so we'd have negative 1/2 plus 1/2 I, or negative 1/2 minus 1/2 I. With the I in it, they're called complex numbers, and the answers, those answers are always in the form of A plus B I. And that A and that B aren't the same as this A and this B. We're just saying that there should be a number, and then a plus or minus, and then another number, and then the I at the end. That's the right format. So now we're going to mix it up, and we're going to look at 4 problems, and we're going to talk about how you tell which method to use. So in this first example A, the only letter that's in there is an x squared. So I would use method 1. I would get that x squared by itself by dividing both sides by 3. And I get x squared is equal to 20. And then I would take the square root of both sides, positive and negative, which gives me x is equal to, and let's break down that 20. 20 is 2 times 10, and then 2 times 5. So this is positive and negative 2 times 2 times 5. And here's a pair of 2, so it would come out. So I get x is equal to 2 square root of 5 and negative 2 square root of 5. This one has a 3 in front, but each piece could be divided by 3. So the first thing I could do was pull out that 3. So let's see what happens if I pull that out. So when I pull out a 3, I really want to be able to check to make sure it could be distributed back and get the same thing as I started with. And now I have 3 terms, so I can look to see if I can do 2 things that multiply together to get 4 and add together to get negative 4. And I see that that could be negative 2 and negative 2, so I can keep factoring. So the 3 would stay out in front, and then I would have x minus 2 and x minus 2 equals 0. And now I've got 3 factors. So I set them each equal to 0. 3 equals 0, x minus 2 equals 0, and x minus 2 equals 0. This doesn't work, so we just cross it out. Here we would add 2 to both sides, so we get x equals 2. And here we'd add 2 to both sides and get x equals 2. This is really 2 answers, but usually we only write it once since it's the same answer repeated. So in C, I would start off by saying, can I find 2 things that multiply together to get 13 and add together to get negative 6? Well, the only things that multiply together to get 13 are 1 and 13. So that doesn't work so well because those don't add together to get 6. And when that happens, that means I have to use the quadratic formula. So this problem tells me that A is 1, B is negative 6, and C is 13. It already equals 0, so that's why I can just read that. So the quadratic formula says the opposite of B, so that B would be negative 6, plus or minus the square root of B again, squared, minus 4 times A, which is 1, and C, which is 13, all over 2 times A, which is 1. Again, I'll simplify in 3 pieces. This is the first piece right there. The opposite of negative 6 would be positive 6, plus or minus the square root. And then I'd want to get one answer for all of this. I would just type it into my calculator just like I see it. gives me negative 16 all over. And this right here is my third piece. 2 times 1 is 2. Well, negative 16, the square root of that is 4i. So we'd have x equals 6 plus 4i over 2, plus or minus 4i over 2. And that, again, we need to keep going because we have to put it in the right format. That 2 goes to both pieces. So I'd have 6 over 2 plus or minus 4 over 2i at the end. And I can simplify that. 6 over 2 is 3. And 4 over 2 is 2. So I'd have 3 plus 2i and 3 minus 2i as my two answers. And finally, in this last problem, I have something that's being squared. And so I would use the square root property, this method 1. So the thing that's being squared is already by itself. So I would take the square root of both sides, plus or minus. On the left side, that cancels out and just leaves me with 3x minus 4 equals plus or minus, and the square root of 16 is just 4. Now it'll be a little bit more helpful if we write that as two separate problems. So we would have 3x minus 4 equals positive 4, and 3x minus 4 equals negative 4. And then we'd add 4 to both sides here, which gives me 3x equals 8. Divide by 3. I'll just leave that as a fraction. X equals 8/3 since it doesn't divide evenly. Over here, we would add 4 to both sides also. But when we add 4 to both sides, we get 3x equals 0. Divide by 3, and we get x equals 0 as our second answer.